Hello, good morning, good afternoon. Let me explain today what is line-to-line voltage, line-to-neutral voltage, what is line voltage and phase voltage. So remember that we have configuration even in delta or Y when we have three phases. Let's start with this Y configuration. We have three loads. These three loads are CA, CV, and CC. So we define VAN, like voltage between a line A and neutral N, so line to neutral. This is basically the drop of voltage in here. And then we define VAV as a voltage drop between these 2 points. The voltage drop between A and B will be equal to VAN minus VBN. So we have here the voltage drop between VAB is equal to this VAN and then minus VBN. Okay, we can do the same for the three others voltage line to line, and then we can compute what is the relationship between two types of voltages. Well, let's assume that we know what is the voltage between a line and the neutral. Right? Let's assume that we know this VAN. If we know VAM, line to neutral, we know also B and C, so we know all these three. Remember, so we have here this expression, V voltage line to line is equal to voltage line to neutral minus voltage line to neutral with the other one. So basically we have those phasors, and we can compute this value by using complex numbers, or we can use graphical representation. For example, I can represent like, well, this minus B and N, so this is minus B BN, and then so I have summation of this part plus this part, so I can sum up these two vector, right? And then this is why I have here VAN. We can do is also this in numerical way, and in this numerical way the first observation is the voltage line to line is always greater than voltage line to neutral in the sense of the magnitude. We used to call V phi to the voltage related with the phase, and this V phi is representing the magnitude of this voltage line to neutral. Because we are assuming balance sequence, VAN and VBN are the same in magnitude, but they are shifted 120 degrees. So if we compute these two numbers, these complex numbers, so we have here, this is on the right? Well, the first observation that we have here is the next. Well, first, the magnitude of the line-to-line voltage is always a square root of 3 times the magnitude of the line-to-neutral voltage. The second observation is line-to-line voltages forms a balanced three-phase set of voltages. So likewise, we have the original line-to-neutral voltages forming valence. This one are forming a balance system. So the line-to-line voltage also are forming this balance system. So they cancel out if we are summing up the three signals. And the last observation, the third observation, is like, well, the set of line-to-line voltages leads the set of the line-to-neutral voltages in 30 degrees, right? So this is always leading, this is leading, and this is leading. So we also observe here, right? If we want to compute what is a line-to-line voltage, we can use the reference and then scale up by 3 and shift by 30 degrees. Okay, so we are going to use this terminology, and this terminology is the typical terminology which is used by power engineers. Well, the first definition is what we call line voltage. Line voltage refers to the voltage across any pair of lines. For example, between A and B, this VAB refers to the line voltage. The second definition is phase voltage. Phase voltage refers to the voltage across a single phase. And this phase voltage is the voltage that we use when we want to simplify three-phase circuit in just in one phase by this single phase equivalent circuit. So if we have Y connection or star connections, so we have to transform this line voltage to phase voltage. In delta connection, remember, so delta connection is something like this. We have between A and B, we have between B and C, and we have between A and C, right? So in delta connection, actually line voltage is equal to the phase voltage. The next definition is line current. Line current is defined as the current of a single line. Well, easy to remember, right? The current that goes through a line. And phase current refers also to the current that goes through a single phase. Well, in Y connections, line current is equal to the phase current. So in this case, in this particular case, we have this start or Y connection. So the line current that go in this line, A to N, is the same like the phase current. Finally, we're going to use B phi just to refer to the phase, and BL to refer to the line or line to line. I phi to refer to the values related with the phase, and IL to the values related with the line.